the Bangalore Astronomical Society. We are here live for observing the total lunar eclipse. Akash, who set up his telescope and the camera from US location, California, he's going to live stream it for us. And you can already see that the image of the eclipsed moon. So we have an eclipsed moon. We are here live for. So the eclipsed moon is visible right now, and you can notice that we are heading closer to the full total lunar eclipse. So along with me, I have Akash. Let me invite Akash for this. Akash, welcome and thank you so much for volunteering to live broadcast it.
Hi, Naveen. Thank you. Yeah, I'm here in the Bay Area of California. The time here is about 3:38 a.m. Uh, and I am live streaming the lunar eclipse through my finder scope. I'm sorry, the focus is a little soft because the finder scope optics is not very good. Um, and Yeah, currently it is the partial phase. Through the live stream, you can not see, it just looks like it's cut off, but to my naked eye, because the eye's dynamic range is much higher, that means it's sensitive to much larger scale of light. I can actually see the red color already on the dark side visually. uh, so that's my introduction and what's going on here. Uh, the moon is setting, and unfortunately, my tracking is also not good because of polar alignment issue. So I'll keep recentering the moon every few seconds as it drifts out, and we should start we should be seeing the totality begin in about 30 minutes or so, if I'm not mistaken. Yeah. Okay, back to you, Naveen.
Awesome. So thank you so much, Akash, again. We have Obli from Coimbatore area. So Obli, over to you. Just a short introduction.
Uh, Hi, I'm from Coimbatore. My video is not working for some reason. So I'm an astronomy educator and I teach astronomy, and I'm a member of Bangalore Astronomy Society. And yeah, I'm excited about this eclipse, and I'm as excited as you all are. So that's about me.
Awesome. So let us go.
Was I audible? Yeah.
Yeah. So let us go to Shashi. Hi, Shashi. Welcome.
Hi, Naveen. Excited to be part of your team to view the eclipse. I'm here from Bangalore and I've been into astronomy for the past couple of years. And this is my so the first eclipse that I saw was in January 2018. And that was a spectacular sight. That was the last total lunar eclipse visible from Bangalore. So this time we are not fortunate enough and to view directly from Bangalore, and we have Akash and everybody else across the world to live stream it for us. So thank you for the opportunity.
So we have next Sudash.
Hey folks, good evening. Very excited to see the blood moon, super moon, pink moon, strawberry moon, whatever moon you can actually think of, and excited to be presenting this live to you from a few locations across the world where the eclipse is happening, and excited to be part of the group to bring you things live and also answer some questions regarding the superstitions that you may or may not be aware of. Hopefully, during the question answer session, we will probably break down a lot of things actually one by one. Over to you, back.
Thank you, Sudash. Now we have Vishwanath, who's been almost a backbone now. So Vishwanath.
Hey Naveen, hi everyone. Yeah, very excited to be here. probably, I think the next chance what we'll get to see a lunar eclipse is somewhere in 2025. And I'm very happy to, I'm very thankful to Akash and happy that we are able to live stream it so that all our viewers can see it. Yeah. Over to you, Naveen. Yeah.
Awesome. Okay, thank you so much. So welcome to all the people who are watching on the live stream. What we are going to do now is we're going to go ahead and ensure that the questions are mapped on the website, on the live stream that we have. So please use the chat message on the YouTube live so that we can answer the question live. We'll also be taking up few questions and answering them. So live right now, what you're seeing is a screen which is displaying the live view from the Bay Area where Akash is present, and this is uh, the the moon that is eclipsed as of now. So if you see that the moon is eclipsed and a large portion of the moon is covered now. So you can notice one distinct thing. Today is a full moon day, and being a full moon day, you are seeing the moon in the eclipsed form. So that's a first thing that confirms that eclipse is going on. Okay. Right now we have a part of the moon covered, and when the part of the moon is covered, we call this as a partial eclipse. So right now, what you're observing is a partial eclipse of the moon, where the moon is entering the umbra region of the Earth's shadow. So as the moon does not have any light and it enters into the shadow region of the Earth. So you can imagine in the space, the shadow of the Earth is a big cone. And when the moon passes along with the shadow, there is no light from the moon. It is not a self-luminous body, so it reflects the sun's light. And when the moon is in the shadow, there is no light reflected back from the moon, and hence we see it as an eclipsed moon. That's the whole phenomena here. So what you see is a partial eclipsed moon, and we are waiting for a totality and a total lunar eclipse. And when it is fully eclipsed, when we say fully eclipsed, the moon gets into the shadow cone 100% completely, and we will be seeing uh, the the golden red or a golden yellow, golden color moon. Okay, that's what we are waiting for. So let's hope for this, and I'm going to explain things as we proceed with this. Okay, Akash, how is the weather conditions there?
The weather is clear. It's cold. I am wearing a light jacket. That seems to be enough right now. I have no sense of what the temperature is. Probably in the either maybe it might be like 10-15 degrees Celsius. But the skies are very clear. The hazy feeling is because of the quality of my finder scope optics. My telescope has way too much magnification for me to show you anything through that. And this is extremely light polluted sky. So probably bottle 8 or bottle 7 at best, and probably bottle 9 even at worst. But I still can see a few stars of Scorpius, and the moon is currently near the head of the Scorpion. Near, I think, I don't know what the star is called, but it's the one next to Juba. Yeah.
Awesome. You can go ahead and center the moon for a moment while we take up. There are a lot of people joining in from Bangalore and from India. So the announcement is we don't have a lunar eclipse visible from Bangalore or from in India. So this is live from US location. So Akash is in USA, and he's broadcasting it live from there. So any people from Bangalore? No, you don't see it because it's a daytime and moon is below the horizon for us. Yes. Okay, so one of the things that a lot of times people talk about is this lunar eclipse really a rare event? The answer is honestly, it is a special event for sure, but is it rare? No. The shadow of the Earth is always there. It is just a mere coincidence of the orbital path wherein the moon gets into the shadow of the Earth, and typically you will see two lunar eclipses in a year, or as much as like 5 to 7 lunar eclipses depending on which location you are. And most of the times these the shadow is are way away from the moon because of the tilt of the uh, lunar orbit across around the Earth, so you don't see them. Okay, so yes, this is a special event. Yes, uh, they are rare. They are not an everyday event, but then they are not so rare that you have to be scared of. Yes. Okay, Sudash and Obli, would you like to add anything on this now?
Yeah, so eclipses are like one of the most fascinating things about the skies. Of course, like Naveen said, they are not very rare. On an average, you get an eclipse every year. If you take out a decade, so if you total the number of eclipses in a decade, it comes out on an average like there is at least one lunar eclipse every year on an average. So it is not rare. Okay, of course, not everybody gets to see the eclipse all the time because you have to be in the night. It has to be, you have to be in the nighttime zone for the moon to be up in your sky to be able to see it. So unfortunately, we are on not that part of the world today, but still we have our friends from across the world who will be telecasting it live. Again, so in due course of time, I think we'll discuss about solar eclipses now whose visibility from a particular region is even more rare than a lunar eclipse because of the shorter size of the shadow. That we'll discuss in due course of time. I'm sure experts will talk about all kinds of eclipse. But yes, lunar eclipses are not bad and they are not rare as well.
Awesome, Obli. Thank you so much. Yeah. Now, Obli, when was the last time you observed a lunar eclipse?
Naveen, can you ask again? I didn't hear.
When was the last time you observed the lunar eclipse?
It was in 2019. There were two eclipses in the same year, two total lunar eclipses. In 2019 on Jan 31st and then July 17th. In the same year, we had two total lunar eclipses in 2019. So that was the time, 2019 or 18, I think it is 2019, two eclipses that we observed it from Coimbatore. And we had, one of the eclipses was in the late evening after the moon had risen. The second eclipse was in the early morning before the sunrise. So despite that, it was in the early morning, the second lunar eclipse, we had about 120 people who had gathered in a small lawn space, and we made sure we gave food to the people, so to make a point that you can eat during the eclipse. And it was a fun time. Yes, July 17th, 2019 was it? Yes.
Awesome. So let's get Akash back on. Akash, we see that the very small portion of the moon is visible as of now. So can you give us a live update on how are you feeling? What part?
So I'll repeat this important piece of information. The dynamic range, that means the range of brightnesses that a camera can capture versus the eye, is extremely different. The eye is actually amazing. It is sensitive to a very, very wide range of light levels. So if I look visually at the eclipse, the moon looks like a dark red ball uh, with a white portion on the top right here. And what you are seeing on the screen is only the top right, because if I set the camera exposure to match to show you that part, then it will show you only that part, and it's not able to show you the rest of it, because the range of intensities is too high for the camera, but it's not too high for your eye. So actually I see it like as if it is imagine that you had Mars with a polar ice cap, but the polar ice cap is extremely big. That's what it looks like here. Let me just readjust the telescope.
You can just readjust the telescope and bring your the uh, the screen that is showing you the controls. You can just hide them so that we can see the full.
That's right. Okay, sorry about that. Yes. So in the meantime, actually this finder scope is shooting through a finder scope that is on my telescope. But in the meantime, I'm actually looking at the eclipse through my telescope's eyepiece, and I happen to have captured what you call an afocal shot of it on my phone with my phone camera kept at the telescope eyepiece. And this looks a little more representative of what you see in the sky visually. And I'm going to share it to the BAS Telegram group. If somebody could reshare it on the on the Zoom, that will be helpful for me. Or I can also try and reshare it. Actually, can somebody take over sharing and show this particular image? This is closer to the visual appearance right now. The outer circle that you see is actually the circle of my eyepiece, the field stop of my eyepiece, and in that you are seeing the moon, and you can see the red color in my phone shot.
Naveen, I can show the screen share if it is necessary.
Yeah, let me stop this so that you can take over and show that picture.
Okay, so let me just show you the simulation right from the website, the timeanddate.com. This is one of the websites where you can always go ahead and have a look at. And this is what Akash is saying. The moon, and you see that the moon is almost covered or entered into the umbra region of the Earth shadow. This is a small portion of the moon which is still passing through, and the 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 shape that Akash was mentioning, we have it like a polar ice caps on the Mars, very similar. This is the one that we are seeing. So what you're looking at is it's a full moon day, but then the major portion, almost 90% of the moon is in the shadow, so they are not reflecting any light, and this portion is what is reflecting the light. And for all the viewers, you can always visit this website timeanddate.com and then look for in your specific location, is the eclipse available or not, and what time is the start and end. So it's a very interesting one. And you can also go through a lot of things within this website. Okay, that was.
I have a question for Akash. So I think I got the answer now in his live view. So how does it? I mean, how does it look like to the naked eye? Are you able to see the portion of the moon that is already covered?
Yeah. I'm able to see the portion of the moon that is covered. Like you're seeing in my photograph. I'm going to send one more photograph to the Telegram group that I just took. So I can see that the moon is like a dark red color. It's and except on this top right side, it has a cap of white. And the phone again, this is an iPhone camera, and the phone will have a different interpretation from the eye. To my eye, it looks actually the red portion looks darker than the phone shows, and whereas on the live stream that I showed earlier, you can't even see the red portion, right? And through the telescope, I'm able to see the red portion and the white portion, and in between I see this blue that you also see on the photograph. I actually suspect that, correct me if I'm wrong, I actually suspect that that is just because of an optical illusion because of the contrast. So you, at the edge of red, you have a tendency to see bluish. I think that's what it is. But normally I see, even in the telescope, I see red, and it slowly transitions to grayish blue, and then it transitions to this bright white region that is much brighter.
I think
Okay,
it's because of the refraction. Because I have seen an APOD in which they have that violetish color, violetish, bluish violet kind of color. So I think it is because of I don't know, maybe scattering or something like that. I can look it up on the APOD.
Okay. I think we have
So,
the
can I,
photograph
if
showed.
everyone has seen this photograph, can I take over the live view so I can show you? What I'll do is I'll increase the exposure now and see if I can get the red color. I don't know how color faithful these cameras are.
Sure, Akash. Yeah.
But otherwise, you can at least see the sliver. So, let me actually experiment with the controls a little bit, and then I'll take over.
Akash, you should be able to go ahead and do a multi-share. So please go ahead and share.
Oh wow! Okay, I'll do that. Give me a moment.
Okay, so the first one, let us, by the time Akash is coming up, I want to ask Kirti. Kirti, it is most often that people say blood moon, blood lunar eclipse. So would you like to talk about why is it called a blood lunar eclipse?
Oh yeah, I mean when you see the TV in every news channel, there is this super blood moon, and sometimes they add additional words in between: super blood wolf, strawberry moon, or whatever, right? So and then they show all these graphics with blood dripping from the moon or moon in red. I mean, like blood red color and all that. But if you actually see the lunar eclipse, it kind of looks like, I mean, the first thing that you would notice is that the moon has lost all its brightness. I mean, full moon, it's so bright and so beautiful. But when you look at it, it looks just dirty with no brightness at all. And then if you observe the color, it's mostly yellowish color, yellowish to maybe a little bit of orangish color. And also because it is very less bright, it looks like maybe copperish kind of color, but not really blood moon or blood red or bright red or anything like that. So I think instead of calling it blood moon, we should just call it maybe dirty yellowish orangish moon or something like that.
Okay, but
But still,
then where does this blood moon term come from? I mean, why is this blood moon so famous and so much used nowadays?
I don't know. I mean, if you see any, for example, if you go to the planetarium website, they don't call it blood moon. If you go to any scientific media, I mean, like planetariums and stuff, they don't really call it as blood moon. I think it is coined by the media and probably people who want to just sensationalize this event. But sensationalizing the event need not be scary. I mean, they need not use the word blood to make it a sensation to raise a TRP. But somehow this term is being used just to create a sensation. That's it.
Okay. By the way, for all the audience, you see on the screen the moon, which is almost eclipse. We are almost coming to the total eclipse now. And why you see the moon is shaking is Akash is using his finder scope to uh, do the live broadcast. Uh, and then he's trying to adjust that the moon is fully visible. So adjusting the contrast to see the shadow part of the moon, which is in the Earth's shadow. So that is what you're seeing as a dark color. And at the bottom right, you see a small whitish patch available. That is the remaining part of the moon, which is about to enter into the Earth's shadow. So only that much of the eclipse is, I mean, the moon is outside the shadow. In about a few minutes, we will see the full moon will be inside the uh, Earth's shadow, forming it as a total lunar eclipse. And the total lunar eclipse is going to very much look like this image here that we have, which is going to be a golden yellow or a copperish kind of a color. This has got nothing to do with the blood. It has got nothing to do or no connections with the term blood or the human blood in whatsoever. But unfortunately, in the recent media times, you see that most of the discussions happens with the title of blood moon eclipse, blood moon, strawberry moon, and a lot of different things. But predominantly, they want to call it as a blood, and then get scary information and make. The worst part of it is you have the eclipse going on, and along with that, they show some disastrous events taking place. Just to try and connect that the eclipse is bad and it gets to have the disasters in the nature. In fact, there is
Naveen,
absolutely.
I want to ask you one question because I mean we are approaching the totality, and before that, I want to ask you this question. So, if you see the moon at the bottom, you have this bright sunshine, and then if you see the moon, the light is kind of gradually decreasing, and on the top left, it is almost not visible. It looks almost completely black. But if you see a solar eclipse, you have, you have a one line which is separating the bright portion and the not visible portion. But here there is a gradient. So can you explain why there is this gradient?
There are two things. One, when you look at a solar eclipse, okay, in the solar eclipse, what happens is you're looking at the luminous body getting covered by a moon, which is a non-luminous body. So sun is a luminous body which gives you the light, and the moon is coming in between the observer, the basically Earth observer, and the sun. So what is happening is there is a distinct block of the sunlight, and that is where you see the bright portion which is actually radiating the light, and then the block portion which is absolutely blocked by the moon. But then what happens with the moon is actually entering into the shadow region. So when you enter into a shadow, you'll notice that you have, I'm sure all the audience would be able to connect to this. You take a torch and leave the light spreads across. And exactly that way, the shadow will also have spread across in such a way that you have two one. One is an umbra region, the other one is a penumbra region. So right now, what is happening is you will see a gradient of a shadow. So the shadow itself is a gradient, and hence you will have different amount of blockages as the moon enters into this region. Okay, but right now, what we are looking at is the contrast, because some portion of the moon is in the higher gradient of the shadow, and then the one that is bright is outside the gradient, the shadow. So what is happening is because of the contrast that we see, the one that is in the shadow is appearing darker, and the farther inside it is, it will appear darker till the whole moon is inside the shadow. The moment it gets the whole moon gets into the shadow, you will see that the color of the moon will completely change. It will no more be a bright whitish. It is going to be a golden yellow or golden copperish color. That's the reason for
So,
that.
okay, so whatever is in the penumbral shadow, it's slightly brighter, and whatever is in the umbral shadow is completely dark. Right?
And also, as you get to the center of the shadow, it is going to be darker and darker. And there is a gradient. So you always see that gradient in the right now. But the moment the full moon enters into the umbra region, then the Earth's light reflected onto the moon is going to be seen. And that is where it makes it a golden yellow.
Okay. But does the Earth's atmosphere also provide? I mean, cause this? Is there any relation between Earth's atmosphere and this gradation?
Yeah, the light that is falling on the moon during the eclipse is going to be the one that has been bounced off by the Earth's atmosphere. So obviously there is going to be a reddish light. I mean, the red light is the one that is going to pass through the Earth's atmosphere and then hit the moon and then come back. So when the moon enters the full shadow, that is when it is fully eclipsed, the light that we get from the moon and which we see it as a golden yellow is because of the light passing through the Earth's atmosphere. We have the red spectrum of the visible light getting through the Earth's atmosphere and having a reflection from the moon.
Okay, thanks, Naveen. I think now we are about to enter totality, or are we? So, what is the time of totality, Sudash? Do you know? Have we already entered the totality time?
I am not sure exactly, but I think it was supposed to be between 4:15 and 4:45 for us actually. So IST, so we have to convert it to
Actually,
Akash's time.
according to what I know, it's there 2 minutes to totality.
Exactly. We are just about to enter the totality.
Okay, that's great. And when I see the animation on time and date, it looks like the totality time is very less, and it's about probably around 20 minutes or so. But last time, if I remember, probably it was like 1 hour or so. So what is different about this eclipse, Naveen?
So, sorry, Naveen, right. Kirti, if I may
Also, you can take the question. Yes, please.
Yeah. So the shadow that of the Earth, it's like a cone shaped, right? It forms a cone shaped part. Once the light falls on the moon, on the Earth, the shadow behind the Earth will be a cone shaped. So depending on where the moon passes, like inner part of the cone or outer part of the cone, it takes a different time for the moon to go through the shadow. It's basically has to pass through the shadow, right? So if it is like closer to Earth, for example, or like in the inner part of the umbral shadow, then it takes a longer time to go through it. If it's the outer part of the cone where it's thinner, the shadow, it will just exit it soon. So that's my understanding of why there is a difference in the duration of the totality.
So,
okay. So what you're saying is also, I mean, I just remember this now. So basically, the moon, Earth, and the Earth's orbit around the sun is in a different plane compared to the moon's orbit around the Earth. And based on where that moon is passing in the Earth shadow, maybe the time would be also different, right? So basically, you have the Earth's shadow, but if the moon is passing very close to the edge of the Earth shadow, the time may be less, and if it is passing through the center, the time may be more. That's what you were also trying to explain, right?
Yes, correct. Yes.
Kirti, the other part is this. So this image that you are seeing right now, you can notice that the moon is going to.
I'm focusing it right now, so that's why it's moving all around. I'm trying to see if I can get better focus. Yeah, go ahead.
Yeah. So what you see here is Kirti. If you see this is the bigger circle is the shadow of the Earth. So just imagine this moon going on from your left-hand side to right-hand side as a short path. So you can imagine like you can imagine the this circle, and then the longest distance is the diameter. So we have the diameter, that is when the moon is going along the diameter of the shadow, that is when you find the maximum duration. But then if it happens to pass on the top or at the bottom or off the diameter, then you will obviously find it as a lesser and lesser duration for totality. Okay, so right now it is in the totality. Okay, team, we are now from where Akarsh is, from the Bay Area. The moon has 100% entered into the lunar, the Earth's umbra region. So what you are observing is a full total lunar eclipse. And even though the broadcast is showing us different I mean, there is a gradient of the shadow itself. I'm sure, Akash, I want you to explain. Are you able to see the goldenish color for moon? How was your experience? What are you seeing in the sky right now?
So right now, Naveen, you can hear me, right? I just want to double check.
You can block your controls. We are able to see the moon so that we
Okay,
can.
are you able to hear me?
Yeah, we are able to hear
Okay,
you.
cool. So right now, if I look at the sky, the moon looks sort of eerie. I mean, I've seen this. This is probably fourth time I'm seeing it, so I'm used to it now. But it looks rather eerie. Like the moon has almost disappeared into this faint bronze-colored thing, and only the top right edge, which you can see also in this image as the top left edge, that top right edge alone is a little whitish, and the rim around it seems a little whitish more than the center. I suspect that is an optical effect, like an illusion. But because I think because it is at the edge of the umbra, still I can see a white. I can still see that it is brighter on the top right, top left in the live stream, and darker on the bottom left, which is bottom right in the live stream. Um, so you can see that sort of gradient from bright to dark across the moon, and I think that's because the umbra is not like one solid uh, black thing. Um, in fact, because the earth has an atmosphere, that's why we are seeing the red color. I'm not sure if this was discussed, but one way to describe why the moon appears red during a total lunar eclipse is that if you were on the moon, you are seeing the sunlight go through all the places where there are sunsets. So around the rim of the earth, you are looking at all the places with sunset and sunrise at the same time. If you were looking through from the moon, and that's why it appears orange or reddish, just like a sunset or sunrise appears reddish. So that's what I'm seeing right now. I'll There are multiple problems with cameras that are designed for astronomy. They are not designed to produce a accurate live feed. They're more, you have to post process the image. So the what you're seeing here, instead of red color, you're seeing a purplish color, and that's because the camera white balance need to be adjusted. These are various problems with cameras, whereas my phone camera doesn't have that problem. So every now and then I'm sharing pictures from my phone, which are more representative of what I'm seeing with my eyes.
Okay, thanks, Akash, for that beautiful description. So, how high is it in the sky right now for you?
It is about just about 15 degrees from the horizon. Um, it is higher than I thought it would be, but yeah, it's pretty low.
Okay. So I think 1 hour the moon will set for you and the sun will rise in the opposite direction.
I think it might take a little longer than that, given that it's on a fairly southern declination.
Akash, you need to come closer to the mic. We are not able to hear you properly.
Yeah, sorry, I was adjusting the image. I think it'll take a little more than an hour because it's at a southern declination, right? It's in the constellation of Scorpius. So I think it'll take a little more than an hour to set. But yeah, sunrise is expected in about an hour. I mean, I think at least twilight is expected in an hour, probably even sunrise. I have to check the sunrise.
And also, as the sun sets, as the moon sets in the west, exactly the same time the sun should rise in the east, right? Because the Earth is exactly in between the sun and the moon. That's why we are having this eclipse. So as the moon sets in the west at exactly the same time, the sun should rise in the east, right?
I think that's correct. And the sunrise here is at 5:50 a.m. Currently, it is 4:17. So I think it's about an hour and a half.
Okay. That's awesome.
Kirti, yeah. So we have another like member from Singapore where it's exactly the opposite. The moon is just rising and the sun is just setting. So exactly placed on the at 180 degree, I guess. So she's just waiting for the moon to come up, just about. So it's for all flat earthers. Earth is round again. So just the sun is setting in one part and rising in another part. So here. Miru, can you just share your screen and show us the view that you have where you're waiting for the moon rise? Even though I understand the moon is still not up, but quickly, if you can show us if something is visible at all, it's going to be very close to the horizon. Probably you can just let us know.
Yes, now 1 minute.
It is great that we have people from US as well as Singapore from two different ends of the world, showing us the lunar eclipse. Yeah, thanks for joining from Singapore.
The moon is yet to be visible, I guess. I think it's going to be taking a while. So, Miru, once the moon is visible, please let us know. Then we can. Yeah, go on, Kirti. Please go on.
How is the weather in Singapore today?
Miru, you can respond. I don't think she's able to hear.
No problem. Let's wait for.
Yeah. So, Miru, once the moon is visible, you let us know. We can share your screen. In the meantime, I think since we are in totality, Akash can still share his screen. We have a shorter totality. So.
Okay.
So I think I'll just. I think I'll just quickly go through the questions here on YouTube. So why does it look purple pinkish? I think Akash already answered that. That is because of the camera, the limitations of the camera and scope that he's using. And there was another question, what is a finder scope? Akash, do you want to take that?
Sure. But before that, let me make a comment. Right now, it has become so dark, the moon, that to look at it clearly through my telescope, I have to shield the local lights that are in the parking lot behind me. The bright LED lights to illuminate this parking lot, and I have to shield them. So it has become very dark. Normally, when you look at the moon through a telescope like a 6-inch telescope, which I'm using, it is blindingly bright, the full moon. But right now, it has become so dark that I need to shield my eyes from local lights. So that's how dark it is. And as you can see, I don't know if you've noticed me changing the exposure. I've gone from a very short exposure to much longer exposure. Now we are at 230 milliseconds. Earlier, I think we were talking in terms of maybe even less than a millisecond when the moon was full, uneclipsed. So let me answer that question. A finder scope is just a sort of small telescope, very small, low quality telescope, cheap, that you place on a bigger telescope to help you find things. And a small telescope usually has a short focal length and a small aperture, which gives it a wider field of view. So it lets you find things in a wide field of view. And then center it in the smaller field of view. So normally trying to center an object in the telescope to bring it into view is a very hard thing, because the field of view of the telescope is very small. So when you look through the telescope, you are usually seeing a degree of the sky, which is just 2 times the size of the full moon. And so if I put a camera there, I will only see a very tiny part of the moon. And so that's why I am using my finder scope to show you the almost the full moon in its field of view. And the finder scope is, in this case that I'm using, is called a Orion multi-use finder scope. It has a 70 millimeter aperture, and it, instead of an eyepiece, it allows you to put an eyepiece or a camera. So I'm using that with a camera instead of an eyepiece. So Naveen is holding up a finder scope right now.
Yeah, so this is what is called as a finder scope. So you see this, it's basically attached to a telescope, and this has a wider field of view. And what happens is, this gives you a wide field in the sky, and the telescope is pointing at a smaller region of the sky. So you center the object through the wider field, and then you can go ahead and observe the object through the telescope. So this is what is the finder scope. It's a simple, and this finder scope is a 9x50 finder. So you will find this here, 9x50 finder scope. So this is what is a finder scope. So what Akarsh is doing is he is having a camera on this side of the finder scope and then observing it. So it is almost like looking through like this. Okay, so you have the camera right in front, behind the finder scope, and then you are looking through the telescope, finder scope. So basically the name is a finder scope, but then this also is a telescope. It also has the primary objective, primary mirror, primary lens, and the secondary lens. And then it basically is a small telescope. You can consider it as a small telescope.
So there is another interesting question. Why is an eclipse called an eclipse? Maybe I can take that question. So I think eclipse is an English word derived from Latin, and it means kind of fail to appear or get covered. So you have, I mean, this eclipse word is also used saying that, okay, the performance of maybe Mahendra Singh Dhoni eclipsed that of Virat Kohli or something like that, right? So if one person is overshadowing another person, then also this eclipse word is used. So eclipse means to cover or to overshadow something. So I think that's why it's called as an eclipse. There is another question. Will we be able to see full moon in India? So yes, I think Sudash already answered that yes, you can see the full moon, but by the time the moon rises in South India, it will already be, the eclipse will already be over, and you will just see it as a normal full moon rather than an eclipsed moon. Maybe Obuli, do you want to add anything to that?
Which question, Kirti?
Yeah. So do we? So why? Okay. So Abhilash is asking us, do we? Why do we not see this eclipse in India?
Okay. So right. So when the moon rises for us today, like for example from Coimbatore at 6:42 p.m. the moon will rise. So I'm just waiting for the moon to rise here. But the eclipse is already happening, meaning the moon is already in the shadow of the earth right now as we speak. But it is not visible from where I am because from my skies, the moon has not come up yet. Okay. But at the same time, as I'm waiting for my sun, for my moon to rise, the moon is continuously moving through the shadow. At some point in time, moon has to exit the shadow, right? Okay. By the time it comes up in my sky in Coimbatore, the moon already exits the shadow. So what I get to see is like, the moon just coming out of the shadow. It's like just a bad timing for us. Like, had it been 1 or 2 hours earlier, if the moonrise was 1 or 2 hours earlier for us, for example, the moon rise was about by 5:30 or so, we would have seen the eclipse from here. But yeah, the moon has to exit the shadow at some point in time. Unfortunately, at that time, somebody will see the moon rise and no eclipse there.
Okay. So if I want to visualize what you're trying to say, so I have the Earth on one side and Sun on the other side and Moon on the other side, and we are on this side facing the Sun. That's why we are in the daytime. And by the time the Earth rotates and it's nighttime for us, the Moon, which is in the shadow of the Earth right now, would have already moved out of the shadow, so we will not have any eclipse. Is that correct?
Yes, absolutely, Kirti. Yes, and that's why some people get to see it and some people don't get to see it. People who are on the night side get to see it. People who are on the day side do not get to see it.
Okay, thanks.
Just show you an example.
Thanks, Uli.
Let me just show you something on this. So here is a simulation from Date and Time website. So you will notice that this is the moon. Right now the moon is here. I mean, it was previous to the so India is here. And what you will notice is, as I start this timer, you see now we are in a penumbral lunar eclipse. This was what a few minutes before. And once we are still in the daytime, India is still in the daytime and moon is not visible. So the shadows are the ones where the moons will be visible. So you notice right now the actual lunar eclipse has started, the partial eclipse. Now it is a totality, the total lunar eclipse, but still it is not visible. So where is Akarsh right now? Akarsh is somewhere here in this zone. And that is why Akarsh is able to see the moon as a setting moon. Okay, so here is where the Akarsh is seeing this as a setting moon. But we also have Brilani, who is from the Singapore, where the moon is going to raise. So we have one of our volunteer Akarsh where the moon is setting at this portion, and the other volunteer at the Singapore where the moon is about to rise. And what is going to happen is right now the moon has already in the umbral region of the Earth. Now, as we time fast forward, you notice that the Singapore is going to see the eclipse getting away. So that means the total and the partial eclipse will be seen from Singapore. And as we continue this, you notice this. Now we are almost at the edge of the lunar eclipse, but then moon is still not visible in the central region of the India. So only along the Assam, Arunachal Pradesh, that is the region where they're going to see a very, very small portion of the moon which is covered. But then the moon is also going to rise slowly. So the eclipse that you're going to see is not going to be very distinct. Okay, it is going to be it is just going to be lost in the horizon. And if I forward this, now you will notice that it has entered India in the Orissa, West Bengal, all these regions. The moon is visible, but then what is happening is it is in the penumbral region. So this is a penumbral eclipse that is going on. And astronomically, penumbral eclipse is very difficult to observe. You need to be very an expert to look at the differences, especially when we have telescopic or photographic images taken. We can compare the brightness. That is what we can do. As time progresses, I will show you this. So penumbral eclipse is getting into the Orissa, West Bengal, and all the eastern part of the India. So you see this in Bangalore and in Coimbatore where we are. The penumbral eclipse is also not visible because the moon is still not rising for us. And as we move forward, look at this. When the moon is visible for us in the central portion, the eclipse is almost ending. And now this penumbral eclipse as well as the rising moon. The rising moon itself will be orangish in color, like a sun setting and the moon setting and moon rising, sun rising. They are already orangish. So you will not be able to notice any visual difference for a normal user. So this is where the eclipse is going to end, and it's a penumbral eclipse. and you'll notice that it is gone. So it's a repetition. So you look at when the moon is appearing. See, now we have entered, the moon is visible for the east of India, but it is already getting out of the eclipse. And by the time it is visible to us, the eclipse is over. So technically, we will not be able to see the eclipse. We will only have to enjoy as of now from what Akash is live broadcasting.
So Naveen, as I can see here, there is a new bright limb that we can see. So does it mean that the total eclipse is already ending?
Just the camera. I mean, it's the exposure of the camera. That's it. It's a gradient that you're seeing.
Yeah, but I think it has also slightly brightened up visually. I feel like the eclipse is receding now.
Yeah, I think so as well. Yeah.
As of now, what I could see is the eclipse is still going on. So let's look at what is the. Oh, okay. So it shows that the eclipse is just about coming out. Yes, Akash, you're right. Let me show that again. So we only had a few minutes of total lunar eclipse. So you can see that it's the moon is already out, and the umbra region is visible. It is in the penumbra region of the shadow. So it is visible. I mean, you are seeing this bright portion lit up. So the total lunar eclipse is over. I think only Akash and his people around him are the lucky people to see this total lunar eclipse. And all the viewers, you will be able to see the total lunar eclipse through the photo here. Please enjoy the photo here. Okay. The next thing is, irrespective of where you live on the earth, irrespective of where you live on the earth, lunar eclipse is the same for all. So even though the moon is rising for people in Singapore, they are not going to see the same phenomena happening. It is already done. Lunar eclipse, the total lunar eclipse is over even for Singapore people. What they will be seeing is the partial eclipse from now on. Okay. It is not like a solar eclipse where the moon starts covering from the first contact, then the second, then the third and fourth contact. So every location on the earth will see first, second, third, fourth contact if it is a total lunar eclipse. So total solar eclipse. But then with the lunar eclipse, it is just one event. Either everybody see it or not. It's not going to repeat for everyone. So it's a one-time event. That's it. Okay, Kirti, over to you.
Okay, all right. Thanks, Naveen, for that wonderful explanation regarding the eclipse. So there is one question, which is, how long does an eclipse last? Naveen, I think you're on mute. I'm not able to hear you.
Okay, how long does an eclipse last? That's a very, very subjective. Okay, how long will an eclipse last depends on what is the path that the eclipse is going to. I mean, the moon is going to take. How is the moon going to move across the shadow? For example, honestly, I did not expect that the total lunar eclipse today is going to end up so quickly. Okay, I had not seen the simulation though.
But you should see the total solar eclipse, Naveen. It will be over in like a very short duration of time, around 2 minutes or 3 minutes.
Few seconds. Total solar eclipse is few seconds to a maximum like 2.5 minutes or so. Here, the lunar eclipse, the total lunar eclipse, in that way can be anywhere around like few minutes, the one that we saw today, to over an hour or so. Okay, so if it is passing along the diagonal, so we will be able to see almost for about an hour or so. The last time, this picture that you see here, this was taken for the longest duration. The lunar eclipse itself was for almost like 6 hours. Okay. When we say lunar eclipse is 6 hours, we consider the moon entering in the umbra region and then getting out, and the overall duration. And sometimes we also have to look at the penumbral entry and exit. So it can last from a few hours to, few minutes to few hours. Okay. Sometimes what happens is moon does not even completely enter the umbral shadow. It will just glance the umbral shadow and then go. So those are partial lunar eclipses. Partial lunar eclipses, it could be like as small as like 5 to 10 minutes. It could be just the 5 to 10 minutes of a path. But then are these things seen? They're very rare there. Yeah. Most of the times you will see a partial eclipse, 10, 15, 20% going on. Yes.
I mean, there is another interesting question. So Komal is asking,
Hello, is
So
is it on?
I understood what Komal is asking. So basically, Komal wants to know, by that logic, isn't the solar eclipse also the same for everybody? The answer is no. Komal, in lunar eclipse, moon is entering the shadow and moving out of the shadow. We are standstill. The moon is moving and entering the shadow and exiting the shadow. So here you have to look at Earth's shadow as a fixed cone. The moon, which is moving, the cone is fixed. The Earth's cone is fixed. The shadow cone is fixed, and the moon is entering the shadow and exiting the shadow. It's as simple as that. But then, when you look at the solar eclipse, it is the shadow which is moving. It is the shadow which moves on the Earth's surface. So for every person, there is an entry into the shadow, exit of the shadow. So in the lunar eclipse, moon enters the shadow, exits the shadow. In a solar eclipse, the observer, you enter the shadow and you exit the shadow. So that's the difference. That is why every person will have their own version of solar eclipse, and everyone on the earth will have the same lunar eclipse.
yeah, in fact, there are all these, during total solar eclipse, there are all these flights which actually go to the shadow, wherever the moon shadow is. And then they show you the total solar eclipse, and then they move faster than the shadow, and then wait for the shadow to catch up, and then you can see the total solar eclipse again. So one solar eclipse you can see 2 times with this. If you move really fast.
You have a chartered flight and just to trace along the shadow, you can make sure you're always in the shadow. See the eclipse for a really long time.
Yeah.
So, by the way, could somebody share the pictures from the Telegram group again? I want to also do justice to the actual view, which this camera is not doing because of white balance and other issues. In the meantime, I'm also taking pictures with my DSLR that I will share later.
Sudash, can you do that?
Let me do that for everybody. So
Naveen, just screen shared it. Is it okay?
yeah. So just now I've been sharing this. Is it visible?
I may have to stop my screen share, so let me do that. Yeah, I can see it here.
Yeah.
Yeah, this is
Oh,
a
wow.
picture
This
taken
is
with my
beautiful.
phone through my telescope. By putting the phone camera at the eyepiece, it's a method called afocal. It's basically, instead of putting your eye at the eyepiece, you put the phone camera and take a picture. And so this is a picture from the telescope that I'm looking at the eclipse from.
So this is really beautiful. So you have this kind of dark red color, and then orangish color, and then a hue of grayish or grayish blue kind of hue, and then you have the sunshine, which is overpowering light on the bottom. So this is an inverted view, right? So basically, in the live view, we saw that the bright portion was at the top, and now here it is at the bottom. So this is kind of an inverted view, right?
Actually, all the views are flipped differently. So I think the view on the live stream is flipped left to right. The one in the telescope is rotated 180 degrees, which is inverted, and photos are capturing that inverted view. If I just look at it from my naked eye, then the eclipse is the portion that is receding is on the top. The bright portion is on the top, actually.
Yeah, that makes sense because the sun is in that direction, right? So you have the moon setting in the west, and the sun will rise in the east. So the sunlight is actually kind of coming from the east. So
Correct.
the eastern limb should be bright now.
Yeah, so what you're seeing on the top left here is actually the eastern limb. That's correct.
Okay, okay. Okay, that makes a lot of sense. Thank you.
Okay, Akash, you can go ahead. Let us.
Naveen,
You can
I
see
think
that.
you muted.
Yeah, you can see the moon is coming, is getting brighter and brighter, and that is because the moon is moving out of the umbra region of the Earth's shadow.
That's right. Yeah.
Okay, that's great. So, Naveen, I think there was one question in the group asking about the timing of this eclipse. So, when does the eclipse end? Do you know the exact time at which the eclipse ends today?
So for today's eclipse ending, so let's do one thing. Let's go to the demonstration. This itself is much better. So I'm going to just take people to the website that we are going to usually refer to. This is a good one. So people can just go ahead and open this dateandtime.com website. And so here you will notice that this gives you a lot of information about the eclipses. So you just have to go to sun and moon eclipses. And this is the one that is going on as of today. So when we look at this, when is the eclipse going to end? So you'll see that the eclipse is going on right now. 89% is what is covered. And here you will also notice that is the eclipse visible to your location? It will clearly say that is a total lunar eclipse visible to Bangalore. If you click on that, it will say that absolutely no, there's only penumbral lunar eclipse in Bangalore. And that's what I was explaining you here. By the time the moon is raising, we'll have only a penumbral eclipse, and that is about 37 minutes of penumbral eclipse. So, Kirti, for your question, is the eclipse, which is umbral eclipse, visible? Answer is no. There is no umbral eclipse visible, which means no portion of the moon will be covered, will be seen as covered. Other part is, will we see penumbral eclipse? The answer is yes, we will be able to see penumbral eclipse. And this is how the penumbral eclipse is going to look like. So basically the moon is already out of the umbra region. So you will see the full moon, but as it rises along the east, some portion of the moon is already in the shadow and this will be for about approximately 37 minutes. What is the time when the penumbral eclipse is going to end? It's about 7 o'clock, 17 minutes. The penumbral eclipse is going to end. And 6 o'clock, 49 minutes is where you're going to, 6 o'clock, 49 minutes is the maximum. That's what you're seeing. This is the maximum. And then 6:43 is the beginning. So it's hardly for about 37 minutes. So this is for Bangalore city. And you can as well look for any other city exactly the same way. And this simulation will actually tell you how the moon is. So did you notice this is the maximum and the moon is going off? Okay. So
And
this is
also, Naveen, in this website has a live stream of eclipse from somewhere in the world, right?
yes. So you can just go ahead and look for live streams. So you'll see that the total lunar eclipse live stream is happening here. So let's look at it.
I think this is a simulation, but is there a live stream from a particular place?
Live stream. So this is a live stream. So you can notice that there are people who are exactly like what we are doing, they are discussing, and then there's a live stream going on. So there will be a live stream available.
Okay, all right.
The best part of this website is I would want other people to note that anytime you want to know when the eclipse is going to happen, see every lunar eclipse. Okay, let us put it this way: every solar eclipse, 15 days before or 15 days after, you will have approximately 15 days before or after, you will have a lunar eclipse. That is for sure. For every solar eclipse, either before or after, you will have a lunar eclipse. There are very rare that you will find only solar eclipse and no lunar eclipse. Very rare. Now, why is it so? Because the plane in which the moon is orbiting, 15 days, in 15 days, it is not going to tilt so much. So if you see a solar eclipse, 15 days before or 15 days after, we are going to see a lunar eclipse. So if you see 26th of May today, 15 days later, you're going to have an annular solar eclipse. So there is an eclipse coming up. And this annular solar eclipse is only visible in the northern, much of the Europe, much of Asia, northern part of Asia, and then North America, Atlantic, Arctic Ocean. So you can look at this. Let's look at this. So you'll notice that this is this a total eclipse? No, this is an annular eclipse. Annular means you're going to see a ring around the sun. It is not going to be 100% covered. So sun will be smaller in angular diameter, moon will be bigger in, moon will be smaller in angular diameter, sun will be bigger in angular diameter. So you will see a disk. So now you can notice here where the eclipse is. And is this visible in India? No. Is this visible in Bangalore? No. So you can see this here. So India is here and the eclipse is happening at this point and it's gone. So we don't even know that there was an eclipse, as simple as that. Okay. So this is a website that you would want to look for.
So I think there are a lot of questions, Naveen. Sorry, Akash, go ahead, please.
Yeah, so I have a question. How would you like me to set the exposure? Now, we once again have the same problem of dynamic range. The part that is illuminated is much brighter than the part that is not illuminated. So I can't, my camera is unable to expose correctly for both. So it will either overexpose the illuminated part and underexpose the umbra, or underexpose the umbral part. So depending on how I set the exposure, is this good? What is the panel's preference?
If you ask me, I think this is okay. What we have now.
As it uncovers a little more, I'll go ahead and shift it a little more to the to expose for the brighter part.
Okay. Okay, all right. So Naveen, there were many questions on the chat, which Shashi is very nicely explaining in the chat. Thanks, Shashi, for all the answers. So one of the questions that we can probably take, I just saw one here. So will we ever see the dark side of the moon from the Earth?
Will we ever see the dark side? Answer is no. If if you have to see the dark side of the moon, then you have to go to the far side of the moon. Get on to
And why is that? Why do we see only one face of the moon and not both sides of the moon?
Basically, the moon is tidally locked, and it is like the orbital period of the moon, as well as the rotation and revolution, both are same. So it is tidally locked, and you don't see the other side, other face of the moon. As simple as that. So the time taken for the moon to go round once along its own axis, and the time taken for it to go around the Earth, both are exactly the same duration.
Mm-hmm.
And that is why we don't see the far side of it. So just imagine like this. So let's assume that these are the two. Let me just show you this. Let's assume that this is the two body. This is the Earth and this is the moon. And if they are tidally locked, I'm just going to show you like this. Any part on this side of the moon, they're going to move like this. So at any given point of time, they're locked. So you don't see this side. And as the Earth, the moon rotates around itself, it is also revolving. So what happens is the amount of turn it is going to do on its axis, it's the same duration, the same angular distance it is moving along its orbit. So for it to rotate 360 degrees, it goes around the Earth 360 degrees and it nullifies that effect. That's why you see only one side.
Okay, thanks, Naveen. I think that is a bit more clear right now.
So at this point, I'm actually tempted to readjust my exposure to bring out more of the partial face. So to my eyes right now, it is I can still see the bronze red part. It's like to use a very Indian metaphor, it's like gulab jamun topped with vanilla ice cream. So I still see that it's a very uh, dark red um, on the part that you are not able to see on the screen. And like I explained, the eye has a much wider dynamic range, so it can see both the bright and the dark parts, but the camera cannot. So that's what I'm showing here. I'm showing the details in the bright part. In fact, with my naked eye, I can even see the details, the maria, the dark patches in the bright part. So that's how awesome the eye is. And I can see the maria in the dark part also. So that you cannot bring out on this camera.
Yeah, that's true. That's interesting. And Shashi, thank you so much. You have been answering all the questions on the chat as well.
And at this point, Naveen, can you also explain a bit about the nodes? We in Indian mythology we call them as Rahu and Ketu, and we have, in scientifically they are called ascending node and descending node. So can you please throw some light on that?
Yeah. The first one is Akash. Can you just hide your control so that we can see the moon fully?
Oh yeah, sure. Thank you for that reminder. Yeah.
Okay. So the context of the node is very simple. You have two orbital plane and the intersection points. When you have two, you just take a two orbital planes, the points where they intersect. Okay, just imagine my hands were to go one on the along. There are two intersecting points along the plane. Those 2 points are the ones which we call as an ascending node or a descending node. And these points itself, the plane itself will be shifting as the Earth moves around the sun and the moon moves around the Earth. So you have 3 different planes where the motion is going on, and there are intersection points, especially if you're looking at the Earth and moon. We have the 2 points. When moon is in one of these nodes, either the ascending node or a descending node, Rahu or a Ketu, and the moon happens to be a full moon, we have a no moon day. That is a lunar eclipse, not a no moon day. Sorry, full moon day with a eclipse. We are going to have a total lunar eclipse. The same thing when the moon is in one of these nodes and it is a new moon day, then we have a total solar eclipse. So these 2 points are very essential for observing the eclipses. Only when the moon is in these points, eclipse is possible. Apart from that, we will have the position of the moon in different places in the orbit, and hence we don't see the eclipses. But this also gives us a very, very interesting one. Ancient astronomers, I would call them as an astronomers, and the scientists from India, they knew about all these nodes. So that is what they address them as Rahu and Ketu, even though currently there are a lot of scary myths around Rahu and Ketu. But then it is basically the way to calculate the motion of the orbital plane along the space. Anybody else wants to add more on this?
If they're not clear about, they still have doubts about the nodes. So I think it's an elaborate game of shadows. The way I try to envision them is, you have to be in the intersection points. The moon has to be in the right point for the shadow to fall on it from the Earth, or the moon shadow to fall on the Earth. So it's just an elaborate game of shadows that we're trying to humans try to enjoy it, and that's how I would like to vision it up. But yes, the nodes, there are extraordinary amount of superstitions that are built around the nodes, calling them bad times, like Rahu, Ketu, or like not an auspicious time to do things. It's just a point in space, it's not even a thing there. It's just a point in space where the planes intersect. So you're looking at nothing, literally, to call on something to make something out of it. So that's exactly that's around the superstitions that I want to share. Yes, that's all from my side, Naveen, on the nodes.
So basically, I'm just trying to see if I can get some simulations to explain this. Physics students will be able to understand this better. Just imagine two planes intersecting each other and the points where the plane is connecting. The 2 points along the line of the intersection. Let me try if I can get the simulation so that it will be easier for people to visualize it.
Naveen, I would like to add in terms of visualizing nodes, like for them to quickly. So imagine, is that what you were saying, Naveen? Correct? Simulations for the nodes, right?
Yes.
Okay. So imagine you have a table right in front of you, and you have 3 balls, like one for the sun, one for the moon, and one for the earth. You place them all on your surface of the table. Let one of them be the sun in the middle, and then you have earth and a smaller ball moving around the earth. Now you can make them move around all at the same plane of the table. You can make them move literally with your hand, let's say, on the plane of the table itself. But now forget the earth and the sun, the balls that represent earth and the sun that are on the table. Now imagine that other ball that represents the moon, instead of going.
You are on mute.
Sorry. Yeah. So imagine the third ball, which is the moon, instead of moving it around the table, touching the table, move it up and down, like, at a slightly elevated angle. So when you do that, you can naturally understand that the movement of the moon, that third ball, is going to touch the table. It has to touch the table once when it is going below the table. And then when it comes up, it's going to touch the table again when it has to come up above the table. Of course, you're not going to make a hole and make it move through the table, but I guess you can imagine. So the moon is moving at a tilted angle, not at the same level as the table. It's moving at an angle. So it's going to touch the table naturally at 2 points. When it goes down the table, and then it moves up the table on the other side. So now these are called the ascending and descending nodes, which are represented by the Rahu and Ketu terminology. Just for you to visualize, you can imagine doing this entirely on the surface of a table by using 3 balls. So that's one way to visualize. I mean, if that helps at all.
Thanks, Obali. That's a nice explanation about the nodes. So there was one more question here in the chat. So how do 2 bodies get tidally locked? Could Sun and Earth get tidally locked? Anyone wants to take this question?
I can actually answer that.
Okay, go on.
So I don't know about the Earth and the Sun. I'm audible, right? I'm always nervous because I'm outdoors.
Yeah. You are completely audible.
So I don't know specifically about the Earth and the Sun, but I believe that is actually true, that everything in the solar system will eventually get tidally locked. So the mechanism by which tidal locking happens, it's rather complicated. So just like there are tides of the oceans on the Earth, the oceans are lifted towards and away from the moon when the moon is nearby. The moon's surface will also have that. Think in terms of, for example, Newton's third law, if you wish. So the Earth is also applying a force on the moon, and that force, only the center of mass of the moon can be in free fall, that is, follow the orbit correctly. The other 2 parts will experience tidal forces. Now the moon is solid, but still, over the gigantic forces and the timescales of astronomical timescales, it is not so solid. So just like the Earth's oceans will bulge towards and away from the moon's surface would slightly bulge towards and away from the Earth. Now, imagine that the moon was in the beginning rotating at a much higher rate. Then what would happen is that the bulge would, because the non-rigid body is slow to expand and compress, especially something like of the scale of the moon. Think of it like a spring. If you try to compress it, it will take some time to come back to normal. So because of this, that bulge will be slightly tilted away from the line joining the Earth. This is probably the hardest part of this concept. But that bulge is not exactly aligned towards the Earth, but it's slightly misaligned because the surface takes time to bulge up and go back. And as a result of that, there will be a torque on the moon. That means there will be a force that rotates the moon, and what this force does is it will slow down the moon. And over the astronomical timescales, eventually that the speed of the moon's rotation will keep reducing until that bulge points exactly in the direction of the Earth. Then there is no torque, and that happens only when the moon is rotating at the same rate as it is revolving. So it's a complicated process. I learned this explanation from Bernhard Schutz's book called Gravity from the Ground Up. It has a very beautiful explanation of this, which is basically what I said, but I think he might have pictures to explain it.
Interesting. So there are a couple of things. One, the Earth and Moon are tidally locked. Okay. But then when you get to see the Sun and the Earth, we are not tidally locked. But then the Mercury and Sun, they are locked. So, and the moons of Jupiter are tidally locked with Jupiter. So what you see is an orbital resonance. So you will have 2 to 3 orbital resonance, or one-on-one orbital resonance. There are different frequency of orbital resonance that takes place. So what do you mean by that? Every body will orbit along the center of mass. So the 2 bodies which are tidally locked is going to exhibit the orbital resonance actually. Okay. Like for example, Mercury, it revolves. This is what I'm saying. Like Mercury is tidally locked with the planet completes 3 rotation for every 2 rotations around the sun. So they are orbital resonance and tidal locking. Kirti, over to you.
Oh, thanks, Naveen. Thanks, Akash. That's a great explanation. I hope that clears the doubt, the question that Komal had on YouTube. Thank you very much. And then there was another question from my side. So this eclipse, we were unlucky; we could not see from the from India. So what are the future eclipses, and can we see them from India? Anyone want to take up this question?
I checked recently. I think there are 2 lunar eclipses next year. One is on May 16th, 2022, and the other is in November 2022. And I believe the November one is visible in India. The May one is again visible in the US, and it is actually very good timing here. It's in the evening at 8 o'clock or something, not like 4 in the morning. So it'll be much easier and more widely appreciated. It's not a setting moon. I can't. That one is not visible in India, if I checked correctly. But the one in November is. And then I think the next one that is visible in India is only in 2025.
Oh wow! Okay, what about solar eclipses?
Yes, even the November one is not a. Huh?
Sorry, go
For
ahead.
the next 100 years, I don't think there is a solar eclipse, total solar eclipse visible from India yet. At least for that I know. For the next several decades, there is no total solar eclipse visible from India. So I think there is one in 2023 that is happening close to Papua New Guinea, the total solar eclipse, and the next one in 2024 along the United States, like from southwest to northeast it travels. And lunar eclipses, I think even the November the eclipse next year is not. It's only partial, either partial or again penumbral from India. It's not a total. So I just need to check on that. So
basically what we are saying is, if you want to look at the eclipse, solar eclipse, then get out of India to the place where it is happening. Don't wait for
yeah.
Look at it only when it is happening in India. That is not going to happen, at least in our lifetime now.
Yeah. I would say chase the shadows. Don't expect the shadows to come to you. Chase them.
For now, I'll be happy if they allow me to go outside the house.
By the way, there are people who are called as the Eclipse Chasers. These are the people who literally travel across the globe to capture and observe or enjoy every eclipse that is happening across the globe. They just travel to every location. And I'm sure there would be some people traveling to observe this total lunar eclipse as well. And a couple of points here. One, the lunar eclipse is completely 100% safe to watch without any problems. You can just go out, see the moon, and as simple as that. You don't need any special equipments. You just need to just raise your head and then look at the moon. While the solar eclipse, you have to be really, really careful and be taken care of. And this is something that most of the people ask me, Naveen, why are we not supposed to look at sun during the eclipse? The context is, it is not just the eclipse. You should not look at sun anytime. I mean, if anybody is watching this program now and it is the sun is bright and it is not at the horizon, if you look at sun, it is equally dangerous, same as how you would be damaging your eyes during the eclipse, solar eclipse time. Why do we highlight it during the solar eclipse? It is just like the curiosity. Everybody know that there is something happening in the sky with respect to sun. So they would be curious to look up and then see what is happening. And that is a point where they will damage their eyesight. So The solar eclipse, not just the eclipse duration, you should not look at sun anytime during your regular day as well. So that's a myth and correction that we need to go through. And
so let me add to that. In a total solar eclipse, you can look at the sun during totality, but after
Akash,
totality
Akash,
ends,
Akash,
yeah,
on a fun note, lighter note,
yes.
during the totality, there is no sun. You only look at moon.
Fair enough. Thank you. But there is still the corona and the chromosphere, right? So you can see the corona. That is technically the sun.
Yeah.
So
Make
yes,
sure
you
you're
can look
telling
at
us
the
about the
corona
sun's
and the
corona. You
chromosphere.
just confuse the people listening.
Sorry, what did you say, Obili?
It is sun's corona, not
No,
the.
people make sun's corona. People are like, the word corona just, turns everybody on. That just, their eyes being more aware of it, ears being more aware of it. So make sure it's clear that sun's corona, nothing's superstitious about it.
Sun's corona, not coronavirus. Yes. Uh, yes, you can see the sun's corona and chromosphere during a total solar eclipse with the naked eye. But the danger there is you have to time it exactly such that when that slightest bit of the sun's photosphere, the disk, appears from being covered by the moon, what you call as the diamond ring. In fact, your eye would be adapted to the darkness of the eclipse, and that can be absolutely blinding. And so the diamond ring should never be seen. In fact, when we when I saw the total solar eclipse, I actually looked at it with the binoculars. But we were all very careful to say, okay, well before the diamond ring would come out, many seconds before the diamond ring would come out, we all put on our solar goggles and all of that and stopped looking at the sun directly. So yeah, that's very important. Yeah, that's just my addition to Naveen's point. Yes, the sun should never be looked at with the naked eye or with any instrument unless it's a solar telescope.
So, on the same note, Akash, while we are talking about the solar eclipse, you have seen a total solar eclipse. So, can you describe what it looked like, and was it more exciting than the lunar eclipse?
Oh, I think it is definitely more exciting than a lunar eclipse. There is so much to look for in a total solar eclipse that in one solar eclipse you cannot look at everything. And it just happens so quickly. And unless you have your photography setup automated, you can either do your photography or you can do observing. And I said I will not do any photography, so I just looked at the eclipse. And of course, I again, you have to pick and choose what you look for. I didn't see the wavy knife edge diffraction pattern that goes on the earth. You see these wavy shadows. I did not see that, but I did see. I think I did see Bailey's beads and diamond ring with filtered, I think, binoculars, and then I switched to unfiltered binoculars to have a look at the totality. And the favorite part of that experience for me was to see the prominences in pink color in the chromosphere. Or what am I saying it correctly? But I really enjoyed seeing these pink prominences. The corona, on the other hand, I don't actually remember very much of it. It's there in my photographs. I think this particular eclipse didn't have a very big corona. Um, and of course, the sky was a very strange. It felt like a very strange sunset. The sky was. It sort of looked like it is right now. In fact, it's like a nautical or civil twilight. But it was a sort of eerie twilight that is only seen during totality. That was my experience.
Okay, that's great. So, whatever photos we see, maybe they don't really do a justice to the real total solar eclipse scene, right?
Oh yeah, I think it's all very different. Kirti, you've seen it too, so maybe you should share your experience as well. I'm actually, I guess you can see that my live stream is getting dimmer, and that's because I think moon is getting blocked by my car. The telescope is getting blocked by my car. So I think it's time for me to wind up. I think there's about half an hour for the moon to set. So if you don't mind, I'll cut off the live stream and I'll hear the conversation as I pack up.
Sure. I think our timing, we were supposed to be live streaming from 4 to 5. Now it's already 5:45 p.m. And because of this excitement of Eclipse, we have been continuing our live stream. And thank you very much for continuing the live stream so far. It's like it's early morning for you. You have been up all night. So thanks a lot for taking all this effort and showing us the eclipse.
Sure.
So we will just check once if we have the live stream from Singapore. If not, then probably we can conclude. So Ubuli and Mrinalini, do you have?
I think it is cloudy there. Just we can probably give a quick look at it. Miru, is it is it cloudy, or are you able to see the moon at all in the sky yet?
No,
From Singapore.
Very cloudy. No stars, no moon, nothing.
That is just unfortunate, But you guys still have some more time because the moon is just coming up. So probably you can just wait to see the eclipse for some more time. You have some chance. Let us wait for it. Yeah.
So right now, for me, the moon is about 60% illuminated and 40%, maybe 55% illuminated and 45% still reddish. And the sky has turned blue because it's dawn. And still I'm able to see the red color and the Maria on the bright side. I can't see the Maria on the dark side. By Maria, we mean the dark patches on the moon. I can't see the Maria on the dark side. But yeah, it's a beautiful thing to the naked eye, and it's very hard for me to capture that in a camera. Even my DSLR, I had to bracket many exposures, and we have to combine them in HDR, and it's very challenging. So yeah, this is the state of the eclipse. So I think there is still a lot of time for the partial phase to end.
So Akash, if there is enough light, would it be possible to show your equipment from your mobile so that people understand what you use to capture this one?
Sure, I'll have to join Zoom on another device, so on my phone, so I can. Yeah, although I have disconnected a few things, but yeah, I'm happy to show.
Okay. Okay. So in the meanwhile, let's see if we have any questions on the YouTube channel. We still have 36 people watching the live stream. Thank you, everyone. I think at one point of time we had about 150 people watching the live stream. That's a really good number. Thanks for all the people who watched our live stream on YouTube. So are there any questions? If a man is floating in space, will other smaller objects be able to orbit the human, or does orbit start only at a bigger scale? So can small bodies revolve around small bodies, or is there some big scale required for one body to revolve around another? Anybody wants to take this question?
Kirti, I think Akash is ready with the setup, so we can probably show and then.
Yep. Okay. So can somebody pin his screen? Yeah, I think it's already done.
Hi. Oops.
Akash, you just need to mute and drop out of one of the audios. Just come out of mute your audio speaker as well as mic.
Okay, so I just dropped out of the session on my laptop. I'm sorry, it's very messy here. I was trying to get the setup up and running on short order. So you can see this is a very much sort of jury-rigged setup. This is a telescope that is meant for visual observing. I want to show you that shoe is a counterweight because I put a lot of weight on the front. So I didn't have anything else. So I just tried whatever I could find in the hurry. So this is the finder scope, and here's the ZWO camera. The finder scope is not very good quality, but the camera is good. And this camera was connected to my laptop, and I was running an application called ASI Cap, which is provided by the manufacturer. Here's the eyepiece of my telescope. This is a 6-inch Dobsonian telescope, which means it's not really meant for photography. Like if I try to connect my DSLR to this, which would have actually resulted in a much nicer live stream, it won't focus because it's not designed for photography. It's just designed for visual observing. So I had to work with this. My other camera that I could put in here would have a very tiny field of view. And I think a few people saw that in the beginning. So it's riding on, again, a very contraption setup. It's riding on an equatorial platform. This equatorial platform is designed for my 18-inch telescope. So I put the rocker box of my 18-inch telescope and placed the 6-inch telescope inside that. And I'm running everything off a 12-volt power supply, including this laptop and the equatorial platform. And so the equatorial platform is sort of compensating for Earth's motion. And in between, one of my batteries died, so I had to, the drive battery of the platform died, so I had to quickly connect it to the same battery. And so that's why you see all of these wires running around. That was sort of unplanned. So that's my setup in a nutshell.
That's really awesome.
It's very jury-rigged.
You have taken so much effort to set up everything, and the weather also cooperates. That's very nice.
Yeah, the thing is, I don't have a telescope designed for astrophotography, so this is the best I can do. So
this is really wonderful.
Yeah, but I really wish there was a way to put a DSLR onto the 6-inch telescope. That would have resulted in a much better live stream, but unfortunately, it's not designed for it. So, yeah.
Yeah, it was well worth the effort, and it was amazing.
Oh, glad you enjoyed it. I'm so happy to have been part of this. Yeah, I'll of course send you my photos from the DSLR, which are the highest quality, and it'll still have to be HDR fused and so on, but I'll try and find a compromise during totality and send that.
Okay.
So yeah.
Cool. That's great, Akash. So I think now that now we should end the session. And before we end the session, we have to thank all the panelists. So thanks Naveen, Oguli, Sudhash, Mrinalini. Mrinalini has joined us from Singapore, but it seems to be cloudy over there. So hopefully in some time they will be able to see the eclipse and enjoy it. And Vishwa, and all the volunteers who supported to make this happen. Shashi was on the YouTube channel constantly answering all the questions on YouTube. So thank you very much, Shashi, for that. And Likhita, who is our volunteer, helped us a lot to organize this event as well. So thanks all the BAS volunteers and panelists for joining, and special thanks to Akash for being awake all night and showing us the wonderful views of the eclipse. Yeah. Anyone want to say anything? Naveen, do you want to say anything? Add anything?
Yeah, basically you just summarized it, and thank you so much for all whoever is involved in this. And we will be looking forward to come up with many activities, live streaming, discussions, and also be part of the Telegram channel and the discussion groups, so that you can share and learn through the conversation with other amateur astronomers in the group. You could also post your queries and expectations, like what kind of programs, if we do, you will be more involved and more useful for you, so that we can plan for it accordingly. In the meanwhile, be safe, take care, and don't hurry up in buying a telescope. I know most of the people would be already looking at, okay, I need to buy a telescope. Don't hurry up in buying a telescope. Observe through the telescope before you buy. And also read through a lot of books and a lot of materials which will give you introduction to astronomy and deeper context. That is about it, Akash.
Finally, yeah, and finally, please subscribe to our YouTube channel. Please follow us on all our social media channels. Join our Telegram group for more information and more discussion. And have a nice day.
Thank you so much.
The link to the Telegram group is available in the website bas.org.in.
Yeah, let's just post it on YouTube. And thank you, everyone. Have a nice evening. Bye.
Okay, bye everybody. See you all.